Okay, hi guys, I'm right now in the NUS Chemistry Advanced Teaching Lab here at S9 Level 4. So in front of me, I see a Pure Lab HE glove box. You see a pair of gloves here? So now the lab is very dark, we should do something about it. Lights on please! Okay, much better. So now let's inspect what are the various parts in this glove box. Okay, well, inside is a bit dark, so on top here, top left, you see a button. Hope you can see clearly now because I'm using a 360 camera. Do you see that? Lights on, off, on. Okay, great. Inspection, make sure all your reagents, chemicals, the clean wipe, gloves, they're all inside. Weighing balance too. Okay, you see the bottom right, there's a very powerful vacuum pump to have strong suction, creating a vacuum inside there so that any moisture sensitive stuff will not be affected. And you see the pedals below? So our hands won't be free later because our gloves, our hands will be inside there. So you need to use your leg to pedal. Here we see two antechambers, the large one and the small one. We try to use a smaller one because it's easier to suck out all the gases and flush it in with N2 gas. Big one takes about half an hour, so be very careful. There's a logbook, and before you use this glove box, always check the control system here, write the numbers and then fill it in. So today, since I'm using this to demonstrate the use of the glove box, we're going to do the same thing. Yay! So the date today is 28th of June 2017. My name, Funman. H2O level, we check this water level, 0, wonderful. O2 level, 0.1. Nitrogen level, it didn't say. How? Okay, right. So we'll be using the small antechamber. Okay, so we mark this is a filming the glove box with 360 degrees. Okay, so I'm going to put this camera inside the glove box so they can have better visualization of what's happening inside there. Okay, the last time I used my Google Glass, it was limited view. So before you do anything, always wear a pair of gloves. I'm going to put it inside and see later. Okay? Right. So right now, this stopcock here points to the right side. It says refill, that means inside solid nitrogen. It is safe to open the chamber. Small antechamber. Notice how my hand unscrew it. No longer tight. The catch, do it with both hands, very carefully. Okay, don't make swing. So I'm going to put you inside there and I'll see you later. Okay. All the way in. Hear the sound? We are seeing the light. Welcome back. Yeah! Carefully taking you out. So hello, wave, hello. Now we are outside, you see us? And the camera, you are inside. Yay! Now check out how it looks like 360 around the globe inside the glove box. See the surrounding, see my gloves. The first thing to do is to put on a fresh pair of gloves. You see, although my hands are inside the latex gloves, we need more protection for these black gloves. Think, what if later we puncture it or if there are some chemical spills? So we are always preparing like several sizes of glove box inside the glove box. Lamau, pun unintended. So now you see my hands. I've worn these L size gloves. We are ready. Ensure that you have dexterity. Make sure your fingers are moving freely. So see this chemical in front of me? It is secured tightly by the retort stand. You see now, the glass syringe? We use it to extract some of the liquid chemicals inside the glove box. Presumably it is moisture sensitive, such as phosgene or titanium tetrachloride. That's a simple covalent molecule. It will just vaporize instantly. Now, next we see this small beaker housing a bottle, a chemical wrapped in an aluminum foil. Why do we wrap it up using AL foil? It has to be because it's a light-sensitive chemical, for instance, NBS, and bromosuccinimide for radical reaction. So now I'm reaching out for a rubber septum, and here we have a setup ready. Show you how to insert and secure a rubber septum. So see, you force it, rotate it into the neck of the round bottom flask, and rotate, move the flap, and fold it nicely to secure it. Here you go. Yay! Next, in front of us we have this analytical electronic balance, highly accurate up to 4 decimal places in grams. We use it to weigh solids, primarily. And this red color stand is actually a substitute for a cock ring. In fact, it is more stable than a cock ring. Now, I am reaching out for metal spatula to scoop solids for transfer. This brush I'm holding onto now is used to clean up the area. So you brush it inside the glove box. You see, I'm doing it with a mix of guilt and diffidence. It is always good to be responsible in the remit of the experiments, areas that you deal with. Oops, Lamau, I forgot I'm wearing the gloves in a glove box. Lol, can't touch my face. Hi. Okay, so that quinoa is pasted, it's gone, but my face is still itchy, so let's get me to wrap things up here. Now, you're going to discard the waste inside the chamber, the antechamber, of course. If they are dirty, wrap them up first, okay? All the waste that you deal with inside the glove box. You see that my hands have to be flexible in reaching out the various parts of the box. Sometimes we might even have to reposition our whole body in order to rotate the big stopcock tab to unlock the antechambers. So my left hand will be impossible to do so. You can only do this with your right hand. Okay, so here in front here we have a round bottom flask and another one, a 2-neck round bottom flask. Let's seal it up with a rubber septum. So you watch carefully. I am handling a needle, and this is a special kind of needle that can click into this robust glass syringe. You can't tell, but it is heavy. It is heavier, it's more durable than the ordinary syringe. So you pick up the needle, aim carefully and rotate it into the screw, and you will sense and feel a clicker motion. Tuck! That's when it's tightly sealed and secure. So now we poke into the reaction mixture, withdraw a certain amount and dispense it via cannulation or in other ways. Here I demonstrate that it's a post-transfer of air into the reaction mixture. Yes, we are transferring air. Using one hand to grip the sealed round bottom flask, the other hand maneuver the syringe with the needles. Apply force with care, okay? Carefully with sense. Control and slowly push the needle inwards. You now see that it's going in. Slowly with patience. Even if you're not a doctor. Okay, now I remove the syringe. Imagine that I have added everything I needed. Dislodge the needle from the glass syringe. Take it out. And see my left hand now, holding a very happy looking round neck RBF. It is now sealed by a rubber septum. Okay, so here we have successfully transferred fresh air into the round bottom flask. And I'm putting the round bottom flask into the stand. You see, it's so stable. It doesn't move, the neck stands still. Next, I am going to remove this RBF from the glove box, and before me doing so, okay, I'm going to simulate this. Remember to unsecure the screw guarding the antechamber, if not you can't open it. So now, after it's being unscrewed, open the vault, reach to the antechamber, okay, close the vault and screw it tight. Done. So now what am I doing? You may wonder, you see, I'm trying to push the RBF as far as I can reach so that later on it's easier for us to take it out from the antechamber when you have the flushing motion of the vacuum and nitrogen gas. Recall the antechamber is very long outside at the beginning. If not sure, revise this video again. Okay, so let's suppose everything is done. I put back the round bottom flask into the glove box remove the rubber septum, and I'm taking you the 360 camera out of the box. This is what the round bottom flask will see, okay, if there's a pair of eyes on it, okay, so the camera is going to depict that. Enjoy the experience later. It's going to be in total darkness with vacuum and air see you in a while. Hey, wait. What's going on? Oh, I forgot to remove my gloves, remember? Inside the glove box, I had a pair of gloves with me and now it's useless. Hi! Present for everyone! Thanks for watching! I hope you have enjoyed the 360 experience. Learn better, reimagine chemistry.